we're going to find any critical numbers for this function y equals x plus 2 to the positive 2/3 power. And as we've been doing, please remember, it's a critical number. First and foremost, it has to be a point on the function. And then there's some other details to check with the derivative afterwards. So if this version of the problem makes it harder for you to determine if there's any undefined values, let's look at it this way, where we have the 1/3 power, otherwise known as the third root or cube root, and then x plus 2 quantity squared is one way to write this. The cube root is actually quite informative to us. It doesn't matter if this value is 0 or positive or negative. The cube root can calculate all of those values. We don't even need to think about what the 2 might do to this. And I'll just put a little notation here that there are no undefined values. Alright, let's see if that is useful later. Now we can check the derivative. Power rule would say it's 2/3 multiplied by x plus 2, the quantity, subtract 1 from that exponent, that would be the negative 1/3 power, and then we would multiply by the derivative of this quantity. Well, the derivative of that quantity is just 1. Uneventful, but I better think about that at least. And let's do a little rewrite. Negative exponent, I don't need to worry about writing 1, so I have 2/3 x plus 2 to the 1/3 power, which is the same as 2/3 multiplied by the cube root of x plus 2. Now we investigate. When is the derivative equal to 0? Well, a fraction is equal to 0. We've done this many times in my class now. A fraction is equal to 0 when the numerator is 0. Well, the numerator is 2. It's not 0. So I'm just going to put the word never right there. What about the derivative being undefined? Well, that would mean that the denominator is 0. 3 multiplied by the cube root of x plus 2 is equal to 0. Well, 3 is not 0. Basically, what we're trying to find is when is x plus 2 equal to 0. I'll put that just as a question mark. That's my goal. And that happens when x is negative 2. Now, that might have been a little bit too fast. So let's back up here. We have a function that is never undefined. We have a derivative that is never equal to 0. But the derivative is undefined when x equals negative 2. Since the function has no undefined values, this is actually an example of a critical number that happens when the derivative is undefined. So our critical number is x equals negative 2. There you have it. Another type of algebra to consider when we're solving. Until next time.